So we see from some of the scientists we visited that they are working in ways as never before across disciplines with others throughout the country and with the government to conduct research and share data. Dr. Bob Thomas has more on how scientists are coming together. Bob.
Good, thank you. Our guests in this segment are Dr. George Crozier, the director of the Dauphin Island Sea Lab in Alabama. Welcome. Thanks, Tom. And Dr. Jeff Lotz, the Department Chair of Coastal Studies and Professor at the Gulf Coast Research Lab in Mississippi. Good to have you with us. Well, this excitement is really fun for scientists, where all of a sudden people are collaborating that maybe used to be even in different buildings. And now we sit and talk about issues, and we bring into the conversation some of the things that our specialty into your specialty, and all of a sudden we come up with new ideas. One of the celebrated ones that I like to use with my students is dinosaurs. You know, when we were young, you knew about 5 or 6 dinosaurs, and everybody knew what they looked like and had this image of what they looked like. And then all of a sudden in the 80s, you know, a functional anatomist walked into a paleontologist's lab and went, you know, you really think that dinosaur stands like that, but it doesn't, because that bone would have to have a muscle mass that looks like this, which would make it stand a certain way. And another one walked in and said, you know, I've looked at cross-sections of these bones, and I'm starting to think these things are warm-blooded, not cold-blooded, which means they move fast. And all of a sudden, the gaits, the way they walk, the way they feed, the way they interact, changed markedly. And the rest is history, what we see on Discovery Channel today about dinosaurs. Is this happening in your institutions, especially in relation to the oil spill?
Well, I think the reaction is curiosity, and it's certainly beyond buildings. I think one of the more interesting ones, we had researchers come to the laboratory, which of course is essentially out in the middle of the Gulf of Mexico, and clean the south-facing windows scrupulously so that they could come back after a storm and look at what might have been blown in or aerosoled onto the landmass that the island represents. We've also been engaged in trying to get the scientists from around the state involved, which was an interesting exercise for us. We had workshops where 115 scientists from 13 different institutions came together to work out a plan to try to do immediate research at the Gulf, and this was different for us.
Jeff?
Well, yeah, we have a number of collaborations going on. You know, science generally is a deliberative and a collaborative endeavor, and it provides not only expertise of different expertises coming together to look at the similar problems related to the oil spill or anything else. It also provides checks and balances. For example, if a scientist has some data and wants to publish a paper, it's sent out to other scientists for review to make sure that you haven't made a big error and your assumptions and your methods are correct. And so that collaborations are very important at that level. There are also the collaborations that were mentioned earlier in the introductory piece that it's important to bring expertises together that are different, and that creates several problems, the most important of which in this day and age with large amounts of data and large amounts of the ability to transfer data is where are you going to put that data and where is it going to be and how are you going to vet it? Nobody wants to put just raw data out to be looked at. You certainly are. But we have collaborations all the way from the University of Southern Maine to the Hopkins Marine Laboratory in California. But most of our collaborations are in the Gulf of Mexico, where the primary expertise, I believe, is in the Gulf of Mexico.
And you're crossing disciplines when you do that as well, not only spreading it around the country and the world, but also crossing disciplines and bringing to bear their information and their perspectives.
Yeah, we have microbiologists, and certainly my area is really in the biological sciences. I'm actually an aquaculturist and look at infectious diseases in marine organisms, but in this day and age there's a lot of interest in gene expression. You mentioned the switch over in the dinosaurs from the old lethargic organisms to pretty fast sort of bird-like organisms. Well, the genomics or the gene expression is something that's coming into play, and you can recognize some stresses through that activity that wasn't available as short a time ago as Exxon Valdez.
Well, I think one of the intriguing things is that the chairman at the lab had come up with an early cliche, and relative to this oil spill, his attitude was, we don't even know what we don't know, which is a very cute cliche. It doesn't get you very far down the road and where you need to be. And I think that this part of the problem that we're dealing with is the urgency of these issues. People wanted to know what was happening, and of course they wanted to know what's going to happen, and that was a terrible mystery for all of us. We'd never experienced anything like this in our environment, and it wasn't particularly useful to transfer Exxon Valdez to the Gulf of Mexico. The circumstances were so very different. And this is, I think, was what was frustrating to me. Everybody within 300 miles of my voice knew what the hurricane would do if it came. And they want to know what's going to happen when this comes. And that was hopeless. We had no clue. And it's made it very difficult to anticipate what we needed to do in terms of research also.
George, the most commonly asked questions these days, and I'm talking about in conversation over coffee, in front of somebody interviewing you in the media, is where has the oil gone? What's your comment?
Well, I think what bothers me is that it's actually fairly honest to say that it's not oil anymore. And I think there's a misunderstanding or a perception of what crude oil was. And that oil started weathering the moment it hit the water 5,000 feet down in the Gulf of Mexico. And so the issue has become now is where is the carbon that was injected into the north central Gulf of Mexico that way? And in what form is it? Is it toxic? Has the microbial community really degraded this substance to the point where it's all carbon dioxide, or is it turning into bacteria that are going to be eaten by copepods to be eaten by fish that go all the way up the food chain? And are they going to be toxics? What components are toxic and remaining in this system? And those are the long-term questions we're going to be stuck with for a long time. So the oil may be gone, but the product of the oil and being exposed in the Gulf of Mexico remains there, and that's going to be the challenge, I think, to the scientific community, is to answer that big question.
Right. Yeah, for the lay public, you know, we heard back on August 4th when NOAA made their pronouncement, they used the phraseology, only 26% of the oil is unaccounted for. The public took that to mean that it's all gone except for 26%, but in fact it was accounted for, the rest of it. So that's, Jeff, do you have anything to add to that?
It certainly is. I mean, you say, well, the oil is gone because it doesn't float. We don't see anything on the surface and oil floats, but as George said, it's not oil anymore. It's weathered oil, partially degraded oil, and it's going to be around for a long time and has been around for a long time. And the issue of how toxic it is certainly one that needs to be addressed, and we in the Gulf of Mexico are well able to do that. We raise a number of species that are native to the Gulf of Mexico in the laboratory that can be used for studies on the oil that is in this condition, not the oil that is crude as it comes out of the ground, but the way it is now, and try to determine what might be the short-term as well as the long-term effects on that.
Well, those are excellent points, because we're still thinking of this as crude oil, and it certainly isn't any longer. And so what the scientific community is dealing with is figuring out not only what's happening out there ecologically, but how is the product that we're monitoring changing, and I think that's very important. You know, another thing that is on everybody's mind and has been repeatedly reported is a comparison of what happened in Prince William Sound to what happened with the Deepwater Horizon oil spill. What are your comments on that?
Well, the comparisons are very poor. A known volume of oil on the surface, close to the shore, delivered rather rapidly to the shoreline. We're dealing with oil that was released 5,000 feet down in a relatively warm environment compared to Alaska. Now it's cold down at 5,000 feet. And I think the question has become, ultimately what we're going to have to decide is whether the use of the dispersants that kept some significant portion of the oil in submicroscopic droplets, which is fine. That's a bacteria-sized, bite-sized particle. That was the whole point of using the dispersants. And I think that has left us with a lot of uncertainty, because it's at 3,000 feet or deeper. It's not even on the shelf, and how long it's going to be there and in what form. And we're going to have to balance that against the question, how bad might it have been on the shoreline if we had not used dispersants? And I don't think anybody really has the answer. The people that are confident about the dispersant being effective are saying, oh, it's going to be fine. There are those of us that are saying, well, we don't know much about deep water in the Gulf of Mexico, and there's a lot of carbon out there. We don't know what form it's in. We don't know what percentage is toxic, and we don't know the impacts on the microscopic community.
Right. And I think the average person is thinking of that they're thinking deep water, but they're thinking the surface world that we all live on. They're not realizing you're talking about 150 atmospheres of pressure down there, just above freezing. It's a totally different environment as well.
And so comparisons to Exxon Valdez are hopeless.
I think that's exactly right. The Exxon Valdez was quite a different animal. However, there are a few things that could be learned from it, and some of them is that there are long-term effects for these oil spills. We saw that in Prince William Sound. So at least we should be prepared to look at this over the long term. Certainly, it was in one of the intros earlier on where they talked about the herring, which is at the base of the food chain, being depleted and not coming back, and after 4 or 5 years. And so these long-term effects from oil spills, whether they're acute, and they're not just acute events, and that's what needs to be kept in mind.
I think one of the things that's going to emerge from this, to get back to your collaboration question, Bob, is that one of the things that we're very excited about is that we're providing a new laboratory space to the Food and Drug Administration laboratory. They have analytical capacity that my little laboratory would never have, but we have the capacity to bring them samples from the environment which they can then analyze. So we're looking at a long-term relationship with a federal agency that I think is going to bring a lot of power to bear on this long-term question. And that's really what it's going to take. I mean, we're faced with, as from Exxon Valdez, 20 years of looking at very subtle effects in the ecosystem, effects that probably only people like us will actually appreciate in every sense of the word. Hopefully that it's just that subtle.
Right. But we don't ever know what the application of those subtle differences are.
No, exactly right. And we have collaborations like that George is mentioning at our laboratory. We have a Gulf of Mexico marine hatchery program, which is an aquaculture program, aquaculture, because we do raising of animals for food in closed systems, weren't affected by the oil, but in fact there's an opportunity to do land-based marine aquaculture to provide animals for studies, as well as to provide, we do know that seafood production out of the Gulf of Mexico during that period was well reduced, and here's an opportunity to look at a way to maybe fill in some of those gaps. And if anybody were in fact lost their business because of the complications of Hurricane Katrina, as well as perhaps not being able to fish during this, that aquaculture is an opportunity, and that's a collaborative program that we have in our laboratory.
Excellent. Well, look, we have just a minute left in closing. Do y'all think that one of the positive outcomes here may be that the nation refocuses some of its interest in studies of the Gulf of Mexico?
Well, I think that the fragility of the system has been more than documented. Right. I think there is going to have to be that concern. And in the wake of Katrina, I hope people will put the two together.
Certainly there's been a bit of a shift in recognizing across the nation how important the Gulf of Mexico is, and I think it's been very much understudied and probably undervalued, and when we hope that we can maintain the interest of the country and the scientific community in the Gulf of Mexico for a long time.
Well, thank you very much. We appreciate you being with us today.
Thank you.
Thank you, Dr. Thomas. Now, we also want to let you know you can find more on our companion website at spillscience.com. There you can find in-depth information about topics related to the spill, as well as video discussions from scientists studying the effects of the spill on the Gulf of Mexico. You may also want to join the discussion on our blog section of the site, where you can engage in discussions with scientists studying the impacts from the Deepwater Horizon oil spill. Again, that's spillscience.com. And that's all for this edition of The Science of the Spill. Until next time, I'm Erin Pickens.
And I'm Dr. Bob Thomas.
This program was made possible by a grant from the National Science Foundation. a co-production by Mississippi Public Broadcasting and the University of Southern Mississippi Gulf Coast Research Laboratory.